And I think we should be live. Hello, hello. Testing, testing. And if anyone is already here, say hello in the chat. I will be looking at the chat live as we go. So if you have any questions on any of the content, put them in the chat and I'll try to answer as soon as I can. Sometimes as going through the content, I might take a break from looking at the chat as I'm presenting, and then I'll come back and answer questions. So we're a minute early, waiting for people to join in. Again, if you're already here, say hello. Let me post hello, actually. Oh, and while we're waiting for people to join, let me actually just pull up a streaming location so I can make sure I can post links there too if needed. And if you also want to put in the chat where you're watching from, that's always kind of fun to hear about. And if you want to provide a little bit more about what you're working on or what you're interested in learning, that's also always awesome for me to hear as well. Let me just get situated here. All right, and it looks like we're streaming all the right places. I'm assuming you all can hear me, but let me know if you cannot hear me, or let me know if you can hear me. That's always good to double check as well. And again, as people are joining in, say hello in the live chat. And someone said hello. Awesome. Welcome. Welcome. And I assume that means you can hear me. So great. I'm going to share some links in the chat. Everything's also in the description as well. So if you're watching the recording of this or you lose the link or anything like that, you should be able to find it in the description as well. I'll share them in the chat though. First, we're going to go through some slides to kind of set up some of the concepts, make sure everyone's kind of on the same page. And then we're going to go through code, and we're basically going to build, it all combines together, but you can kind of think of them as kind of two things, as different parts of your, like, kind of your AI pipeline. We're going to build a fine-tuning pipeline where we're going to download a data set, download a model, train a model, visualize data, evaluate a model, and then do a prediction there. And then we're actually going to take that trained model and then deploy it and give it a UI that we can interact with. So you actually come away with basically a modern MLOps or LLMOps pipeline with all these training steps. And we'll talk about how to more efficiently fine-tune using some techniques like LoRA and QLoRA. Again, we'll talk more about those as we go. And then we're actually going to take that model, and then you'll see how to deploy. So if you stick through the whole thing, you'll go through kind of an end-to-end whole kind of application cycle here, which will be pretty cool, hopefully pretty fun. To follow along, if you want to follow along when we get to the code, and I might share these again as more people join in. The only account I'm guessing you probably don't already have is a Union account. It's going to be where we're going to run this workflow and use the GPUs on it to train the model. It's free to sign up. There is no card required or anything like that. And you get $30 of cloud credit. You do need a GitHub account to sign up for it. It's a serverless version of Union that's really good to kind of play around with the product. And again, we'll talk more about features that are in there as we go. And then this is the code link, GitHub. So you can find the code here for this workshop. And again, I'll go through this again as we get to the actual code part, but kind of filling a little bit of time while people are joining. And it's good to get people set up. You can open up this link and you'll see this open in Colab button. You can run all this locally if you want, but for the workshop, it's usually easiest if people just run it in Colab. That way we can just set up the environment as we go, and we'll start with a fresh, clean environment. So I recommend running it in Colab. I shared the direct Colab link as well. But you can set this up and run it locally. So again, if you wanted to take more time after the workshop and run it locally, that's great too. And someone else said hello. Hello, how's it going, everyone? Where are you all tuning in from? It's always kind of fun to see where the audience is coming from. Right, yeah, so those are the links you'll need. Again, like I was saying, you'll probably need to sign up for the Union account. It can take 3 to 5 minutes to process, and let me know in the chat if you never get onboarded, if you do sign up, if you want to follow along. Hopefully some people want to follow along. I know some people just want to watch too. That's fine. But it is fun if you do hands-on. And again, we're going to go through a whole process of building a modern kind of fine-tuning pipeline for an LLM. We're going to talk about like how we can implement caching, versioning is there. So all kind of like these best practices are built into the tool we're using, Union, which is built on open source called Flight. I'll talk more about those later. Actually, I'll share the flight GitHub real quick too. So a lot of what we're going to do today, you can also implement in the open source that we maintain. So it's at Louisville and Vancouver, BC. Awesome. I haven't been to Louisville yet. Be cool to go sometime. I have gone to Vancouver, but it's been quite a few years, so I would be excited to go again. Actually, next year, I often go to a conference called Pi Cascades, and I think next year it's going to be hosted in Vancouver. So hopefully I can go to that if it's there. I'm in Seattle myself, so not too far from Vancouver. All right, so again, I'm going to go through slides. Links are in the description. I share the links in the chat if you kind of want to get started to follow along. And I'm going to go through the slides, and then we'll go through the code. So this is a workshop on fine-tuning. Basically, we're going to build a fine-tuning pipeline for a BERT model, but this can extend to really any other type of LLM. Actually, you just need to change kind of a few lines of code to, instead of importing a BERT model, you can import other types of models. You just have to have a different type of data for it as well. So we're going to build a pipeline, and then we're going to build an application that serves that model that we're going to train during this workshop. So, and again, I saw more people join in, so I'll just share in the chat one more time. If you sign up here, let me know if you have sign up issues. I know we had an issue with a third-party tool recently, and I think we resolved it, but let me know, and I can ping engineering and get you through, hopefully, if you don't get an onboarding thing in 5 minutes or so. And again, I'll go through this and the setup when we get to the actual coding part. But for now, let's go through the slides and go through some of the concepts. Just a tiny bit about me. My name is Sage Elliott. I work at union.ai. Again, you'll kind of hear about the tools and open source that we're building. In fact, that's what we're going to build our pipeline on today. Also, just noting, like, if you haven't built a pipeline before, we're going to be going through that. If you've done fine tuning before, we're going to be going through that. So hopefully this is valuable, and we're going to be serving a model. So hopefully this is valuable, even if you've done some of the coding, like fine tuning stuff before, but you've never built it in like a modern MLOps pipeline and haven't really thought about that. Hopefully this is valuable. Hopefully too, if you've done other types of models and you haven't, or if you've done other types of models and built an MLOps pipeline, but you haven't done like fine tuning on a LM with parameter efficient fine tuning, hopefully this is valuable for that as well. And you could kind of tear those two parts a piece if you wanted to. Like if you just learn about the fine tuning part and you want to take that code and take away the pipeline piece, hopefully this will be valuable for that as well. So it's not going to be tied just to like our product or anything. And I live in Seattle, like I mentioned. So someone is saying they're here from Vancouver. I run an AI book club too that some people know me from. Right now, we've been reading a new book every month for the past year and a half, and on and off a little bit before that. This month, we're reading the 100-page language model book, which is pretty fun and a pretty condensed kind of version to catch up with like how LLMs work. I'm enjoying it so far. I haven't finished it yet, but we're discussing it next week. And then previously, I've done a lot of work in computer vision, ML monitoring, evaluation, MLOps, and then also had quite a stint in my career of doing hardware and IoT, and then using some robotics around that as well. If you want to stay connected with me, you can do so on LinkedIn. I'm also in the Flight or open source Slack channel. Oops, didn't mean to click on the link. And if you have questions outside of the workshop, that's going to be a really good place to ask them. During the workshop, keep it in the live chat. I will be monitoring that as we go. And about you. So I always like to, again, ask the chat. I saw more people join in. So where are you watching from? What are you working on? Why are you interested in building maybe LM applications or some sort of pipeline? I always love hearing like kind of what people are working on. And again, if you want to stay connected and there's like an official introductions channel, I think we're close to like 5,000 people in the Slack. You can go join that community, and hopefully I'll see you there later as well. And I think we have some really exciting stuff in the next couple months that I'm working on about some different types of events, maybe a type of hackathon that I'm putting together. So if you like doing projects and like want to share your work, I think we're going to have some really cool stuff coming up in the next couple months. And some stuff on agents, of course. So if you're interested in building AI agents and infrastructure around them, I think you're going to really like some of the stuff that we're working on. So fine tuning, also in the chat, let me know, has anyone fine tuned a large language model before? or maybe any type of model before, like a computer vision model. So most of the LLMs that you're going to use are trained on general data. Now, there are some domain-specific ones, like when you go to Hugging Face, like there's specific medical versions of Gemma and stuff like that. But often, right, they took a version and then they fine-tuned it on a specific domain, like in that case, medical data. So usually the LLMs are trained on general data, not your domain, maybe not specific tone, maybe not specific tasks. So this can help the model on those specific tasks like content analysis, support, etc., summarization. You can get a lot of the same results with like prompt engineering too, but it can only go so far sometimes. And one thing that I think is interesting is just like you could do this with, let's say, a ChatGPT API call, or you might be able to get better results or just as good of results with a fine-tuned smaller model that can outperform like those larger base models, which can make them faster. And then also really important sometimes is cheaper inference. So at first, like you might be prototyping with just a base large language model that does a good job, but then when you're doing at scale, you might want to bring those costs down. And a lot of like stuff that you can do in MLOps or LLMOps is thinking about how to optimize and bring costs down and increase efficiency. And so fine tuning a smaller language model to get the good results is a big part of it. Also, if you really want to reinforce safe and compliant outputs for sensitive applications, that can be kind of a big deal. Fine tuning can work for that pretty well. And then another thing right now that's happening a lot is not every single model is trained to kind of do tool calling or function calling for like agentic applications. So you might be taking a small model and then actually training it to be able to call the tools or tools in your list, or not your specific tools, but you'd fine tune it to be like a generic tool calling agent. And then so you can use a very lightweight model to then call different tools in there. So there's a lot of different reasons why you might want fine tuning. And then a note on parameter efficient fine tuning. Has anyone heard of this before? It's often abbreviated to PEFT. And there's a library called PEFT, which is what we're going to use today. So just kind of abbreviations, FFT is full fine tune. It's often what that stands for. So this fine tunes all those weights and parameters in your model. Often they're very big. You've seen like billions of parameters in our model. So if you're trying to fit that all into a GPU and update all those weights, you need a lot of power to do that, or a lot of GPU memory, which a lot of people don't have, like I don't have on demand all the time. So there's different parameter efficient ways that you can fine tune a model. One is called LoRA, which is abbreviated for low rank adaptation. This adds these trainable low rank matrices to the attention layer inside the transformer block. And then you have quantized LoRA, which is the same as LoRA, but when you're loading the model to fine tune it, you actually load in a quantized version. So it combines the LoRA with quantization. So you're basically making a smaller weights and then making a smaller model. You're going to fine tune those weights that you inserted in, which takes a lot less memory than fine tuning all the weights in your model. And then you basically export those weights and then combine them back together with like the full version of the model, and you'll actually still get pretty good results. So for this workshop, we're going to be using PEFT, the parameter efficient fine tuning library from Hugging Face. And oops, didn't copy that in. And we're also going to be using bits and bytes for the quantization piece. So we're actually going to implement kind of what we talked about here in code again in a little bit. And then also, we're not going to use them today, but if you're interested in pursuing more around the quantization and parameter efficient fine tuning space, check out all the work Unsloth is doing. They have some really cool stuff. I'll probably build some examples with them pretty soon too. I like the work that they're doing in this space, but today we're just going to use the PEFT library and bits and bytes. And just kind of an example of what this LoRa adapter looks like is you have these matrices. You have like a large neural network. This is a very simplified version here. And then you're adding in this adapter. Instead of updating all these weights here, you're just updating this adapter. And then you'll see there's some parameters that we're going to pass in when we actually implement this in code. But basically, we're going to make the adapter way smaller than the actual weight. So if the weight was this amount, it'd have over like 16 million parameters here. And we're basically going to condense it down with a smaller matrix that we're going to insert in there. You can adjust these parameters, and I'll talk about that when we see it in the code. But you're just going to start somewhere. Like it's pretty common to start with 8 by 8. So you're going to condense down that matrix to just 65,000 parameters versus the 16 million. So this is way easier to load into your GPU and update it. The model we're going to use for this workshop is a BERT model. But again, like I said, what we're going to implement today, you can really expand it to almost any different type of model that you can pull down from Hugging Face, which is almost every type of model that you'd probably want to use that's open source. If you haven't heard of a BERT model, though, they're really cool. It stands for bidirectional encoder representation from transformers. They were kind of the first transformer model that I feel like really brought LLMs like into production and into the light and started getting people interested in adopting them. It's an encoder-based transformer. So it's if you've looked at like the transformer paper or know how they work, you know that there's like an encoder and a decoder. And the encoder is really good at understanding what's going on with the text, like for text classification or semantic search or named entity recognition. And you can do this with a lot less weights than the generative ones. So the BERT model is actually the one we're going to use today, which is DistilBERT. It's only like 110 million parameters. So we probably don't even need a lot of the time like LoRA or QLoRA to train it, but we're going to see how to implement it. And if we had a really small GPU, then we could still train it on there. And also, BERT models, I feel like, because they're not the cool new like hot one like DeepSeek or anything like that. But when I talk to a lot of companies that are not a LM tech type company, and I ask them what types of model they're running in production, it's actually pretty common for it to be a BERT model. And there's some reasons for that. Like these are really good at classification on unstructured data. So instead of using like a super lightweight classification model from scikit-learn or something that would really struggle, or from NLTK, you can actually train a BERT model like we're going to do today to get really good at understanding something and then classifying it. And then you're going to get really reliable outputs versus doing like prompt engineering on a GPT or something like that. And again, these are really, really lightweight. So if you're running like classification on every single text message or something like that, that would be really costly if you're using someone's API. So instead, you can host this on your own pretty lightweight hardware, and then or on the cloud somewhere like AWS or Union, like we'll see today. And this will be really lightweight, cost efficient. So again, it's pretty common that actually when I talk with someone like a healthcare company or something like that, what type of model they're doing, that they're starting to bring in, it's a BERT model. And then I'll touch on MLOps and LLMOps. Has anyone implemented a pipeline before that might look something like this? This is kind of a very simplified one, but I like to think of MLOps as the set of practices, not really actually the tools. I should probably change this wording. It's a set of practices of using tools that aims to deploy, monitor, and then maintain machine learning models in production. And then I like the terms reliably and efficiently. That's kind of usually what I think about all the time when I'm helping people like implement their pipelines, or when I've implemented my own at other companies. And again, this is really scaled down, but you're probably going to have most of these steps inside your pipeline. Like you have collect data, then you're going to train your model. Often you'll have steps in between them, like pre-processing data, doing something else with data, train a model. You're going to evaluate that model. When you think that model looks pretty good enough based on the data you have, you can ship that model. Shipping really looks different depending on what you're doing. This could be onto an edge device. It could be into the cloud. There's a whole bunch of different variations of this. And then you should always have some form of monitoring or some process for monitoring, even if it's you manually looking. Again, depends on your application. I'd recommend actually using a tool like a Rise or something like that. And then you can monitor when your model is no longer performing as well, or that the data coming into the model no longer matches the data was trained on. And that's called data drift. And it's really important to catch that stuff in production. And then you're often collecting data from production. And then you could take that data and then train a model on that new data. So it's no longer going to experience that quality shift on with data drift. And also just noting on all these points, you're often going back to one of these steps. So it's really common, like you want to build an efficient pipeline, like we're going to see today, that you can rerun from any of these steps. Like you're collected the data, you train the model, you evaluated it, it's not good anymore. You might need more data. You might need to train the model. You're going to be rerunning these workflows over and over again, especially if you're working in like a large company and you have a big team and you're doing a lot of experimentation. Again, then you ship the model, and then you're building, basically this becomes like a loop over and over again. And with LMs, there's some other steps that might be in here, like you might want to version or just do prompt engineering, right? Instead of collecting data, maybe you can actually do prompt engineering, and that might improve your thing enough to get it to work the way that you want to. So there's all these other steps you get add in here. Typically, every time you run this too, you might want it to be versioned. We'll talk a little bit about that later. But just like you'd version your code, every time you run a workflow, and let's say then you produce a model artifact out of there that you're using in production, and then you want to debug why it went wrong later down the road, you'd want to be able to come back and look at like your training data all the pre-processing steps, all the other steps that went into that, and use that for like debugging purposes or compliance purposes. So some fields actually kind of require that more than others, like healthcare and finance. So fortunately, there's so many great tools that make these steps really easy. Like I mentioned, like Arise for monitoring, YLogs, PyTorch for training, Hugging Face, like we're going to use today for all these models. There's so many good tools that you've probably used some of these before. In fact, it kind of looks like the wall behind me right now. But you still need like compute to run all those tools on, and you need workflows to tie the data and tools kind of together. And so that's kind of where workflows come in. These like kind of the core of pipelines. And again, I like the words reliable and efficient. Also making things fast and easy for your development team. So you want to think about these things when you're building a modern pipeline or some sort of pipeline for your team. So one is that we want to think of how to scale your workflows to handle, like if you have really large data sets, can you handle spinning up the compute that you need to process that data and train models? You want reproducibility. So every time you rerun those workflows, you're bringing in the same container. So this comes in with like containerization and Docker. Has anyone used Docker before, by the way? Because we're going to see later, don't be scared. You won't have to write a Docker file. We'll actually see how to create one just in a Python SDK. But it's basically a way for you to find an exact kind of virtual machine container for your code to run in. And then every time you run, it's going to have the same environment. So you're going to get this really nice reproducibility piece to it. And then we're going to track all of our data code. Like you've probably done this with code, but again, like I mentioned, it can be really important to track the whole lineage of your pipeline and have different versions of models that are reproduced. And you can pull down the latest version. You can roll back to the other one if you want. And then we'll have improved efficiency. So again, allows your AI engineers to focus on the critical aspects of deployment or development. Like if you're in biotech, for example, you want to be focusing on the cool science piece, not like managing your infrastructure, which can take a whole team or a lot of time. So it's pretty common, again, too, when I help people like implement their pipelines, that they'll go from doing like experimentation from like weeks to days because they have this efficiency built in. And we'll see an example of what like declarative infrastructure looks like too. That makes it really easy. So you're not configuring all these files or going through another team to kind of get models out there. And then cost efficiency is a huge thing for companies of any size. You want to optimize your resource usage. So every single task, you want to make sure you're not wasting like GPU time when you're just downloading data versus using it for training. And then also just reducing the overall cost of the development time, which kind of comes with the other improved efficiency I was talking about. Again, it's also crazy some of the numbers I'll hear when people come away with like a new pipeline of saving sometimes up to like 67% of cost, which is like kind of wild. And there's kind of like 4 or 5, like, I mean, there's a whole bunch of different little small things you can do that really add up. But there's like 4 kind of, maybe they sound like no-brainers, low-hanging fruit, maybe not, depending on what you've done before. But it blows my mind how much like efficiency and cost they can save sometimes when you implement them. So just to hammer on those a little bit, and then we're going to go into code shortly after this. So you want to optimize for local and cloud development. And again, these are things that you can do in Flight and Union, like we'll see later, but these are just concepts you should keep in mind no matter what tool you're using. So you want to optimize for local and cloud development. So some tools or teams just aren't set up to like build a pipeline locally and then like do the debugging there. You might have to kick off a cloud job every time you're kind of building it and debugging it. So it has to spin up compute resources, and then it has to run the code, and then you'll get an error somewhere in like a console, and then you have to go find it. And doing that once or twice might not be a big deal, but obviously if you've written a lot of code, debugging can take a fair amount of time and retries. So being able to do that locally, and maybe for your pipeline, you can use like a small model or a small sample of your data set, run that locally. A lot of people have pretty powerful MacBooks now or other computers. And so you should be able to run a kind of smaller version of your pipeline. And then you can kick off a larger cloud job with more resources once you kind of feel like your pipeline's reliable and debugged. Leveraging caching in the pipeline, this can save a lot of time and money as well. If you're rerunning, let's say in this case, it's a training workflow, but again, it could be any type of workflow here where we're getting the data set, pre-processing data, and then we want to train our model that. Well, we want to rerun this workflow a whole bunch of times to do like hyperparameter optimization for our training piece. And actually, we'll see this in action today as well. Every time we rerun it, we don't want to get the data set. We already downloaded it. Nothing changed there. So we just want a cache version. We already did pre-processing. We're not going to change how we process it there. So we just are going to basically save those states and then be able to read them into the workflow unless we say don't read in the cache. Task level resource management and containerization. This is a big one that maybe teams don't already think about too. Depends on what you're using to kind of develop your pipelines and infrastructure. So Flight and Union's built on top of Kubernetes, and this is kind of a Kubernetes thing that if you've done Kubernetes before, you might be familiar with this. But basically, every single task here that we're defining, we get to say what compute we want it to run on and what container we want to run that task in. So we mentioned Docker containers a little bit earlier. Again, we'll see this in action, but we'll give it a container. And then almost more importantly, maybe we'll give it precise compute requirements that it's going to load in just for that task. So for downloading a data set, for example, we might just want 2 CPUs and like 2 gigabytes or 4 gigabytes of memory. Then when we go to the training task, we might want way more memory to be able to load in the model and data. And then also you probably want a GPU for any deep learning case. So you don't want to use GPU time and waste that in these like potentially really long tasks. Like downloading a data set can take a long time into a task if you have really big images or something like that. And you'd be burning GPU time that either you're paying for or you're hogging from your cluster that someone else could be using for like training a model. And once you do that too, you can also monitor, did you over provision what you declared? For example, like I put 6 CPUs here, but if it's actually just running everything on the GPU, it might only need 1 or 2 CPUs, and then you could pull that down. And if you over declared a lot, it could save you a ton of money. If it's a little bit, maybe not, maybe it doesn't seem like it a lot. It's a lot, but if you're rerunning this task again a ton of times, it can really add up. Just one last thing is mitigating errors of type safety. If you've done other programming languages, you might already be familiar with type safety, and it's also coming more and more into Python now. You've probably seen type hints, and there's some other libraries like MyPy that you can use to implement this just in any Python project. But this helps you reduce kind of debugging time through the type safety and making sure that you're using the right data coming in and out of a task. And then really just the readability and collaboration piece. This kind of helps a lot too. So again, it sounds like a small thing, but if you're doing this at scale with a lot of people over a lot of time, it really, really adds up. And that's kind of one thing that's really interesting and fun, I think, to think about MLOps is there's so many opportunities for increasing efficiency. And with LMs, there's even more like thinking about how to like max tokens and stuff like that. Again, if you're doing it at scale, it can really, really add up. And who often really, really likes it when you implement more efficiency is often the company or your boss. So it's also pretty common that I see when people bring in like modern pipelines that they end up like kind of owning that team if they didn't have that before, or you get like promotion. So obviously can't promise anything there, but usually when you like if your company doesn't already have this type of stuff or thinking around their pipeline, you see them really, really appreciate it when you bring it in. And today for running this, because we're going to build our pipeline for fine tuning, we're also going to build a pipeline with all those features like we talked about. We're going to be use Union. Union's built on Flight. I shared this before, but if people are just coming in, there's an open source called Flight. All the pipeline piece that we're going to implement today, you could also do in Flight, but we'll also see a feature or a couple features of Union specifically for like serving the model in an app after. So with Flight or Union, you get this kind of declarative infrastructure for getting all those things like we talked about, like do you want caching? What container image do you want? What specific resources do you want for that task? You define this all just in your Python code as you go. And here it's just a decorator on top of a function, kind of like you're writing Python already kind of like you normally would. But then you're just adding a decorator on top, passing these parameters, and you get a ton of features. You can run it in your cloud or on-prem, except for serverless. So we're going to be using serverless today. If you signed up to follow along, this is kind of just a version where we have a cloud that we're tied to, but most people use like our enterprise version. We're going to do the on-prem or cloud or with Flight as well, like I mentioned. And you get the declarative infrastructure. We get versioning, caching, type safety, all the stuff we've already talked about. It's super flexible with a plugin ecosystem, but also you're basically just running Python code in containers. So even if there's not a plugin, you can usually run like any library that you want to in Python in there. Scalable, built on top of Kubernetes. And then again, we'll see this in action. We'll use the Python SDK and see the interface as well. And it's used by thousands of companies. So it's actually Flight's like a really, really popular orchestration framework that people use to build their training pipelines for like a lot of self-driving cars. And LinkedIn actually switched all their large language model workflows recently to Flight, or last year actually to Flight. So like they're actually probably doing similar stuff that we're going to see today at scale in a huge company. So let's build our pipeline. So here's the link to the code again, if you're ready to follow along. And again, links should be in the description as well. And if you haven't already, sign up for the free Union account. You get $30 of cloud credit. We're going to use just a fraction of it. It might even be under $1 because we're so efficient with our resource use. Like we're actually going to implement this. So we're only going to use a GPU when we want to train or validate our model, running evaluation on our model. But for all the other steps, we're just going to use CPUs, which are really, really inexpensive. So let me know when you open this up, and then you can hit open in Colab is the recommended way that I would say run this in the workshop, even though you can run this locally if you want as well. And I'll share the direct Colab link as well. And what I usually like to do, you can hit run directly from here. I usually like to hit save a copy in Drive, and then this will give you your very own copy of Google Colab, so that you can actually like make notes in here. So like you can edit the text, edit the code, and come back to your version of it. But you can always come back to the original version I shared, or start the GitHub, and then come back to that. And I'll also usually keep it updated. So if we have new features or it doesn't work with a version of this when I run this later, I'll fix it. So you can always come back to that original version. So the first thing you want to do is just scroll down, and we have this kind of setup code cell. And go ahead and run this. It should only take about a minute. What we're going to do is install the Python packages. Let me just get this going. Cool, it's working. We're cloning down the repo, and then we're installing Python packages. And it used to take like 4 or 5 minutes, but with UV package manager and doing downloading in parallel, now it usually takes a minute, which is awesome. While that's going, it's a perfect opportunity, if you haven't already, to scroll down. And again, you can sign up. Let me copy that link. Again, oops, that is the weird Colab generated link. Let's get this one more time. So while that's going, it's a good time to sign up if you haven't already. And then also while it's going, I'll show a little bit more about what we're going to build. So this, again, we'll see all the code for this in a second once it's done installing. This is our pipeline that we're going to build. Once you have a Union account, you'll be able to log in. You'll see something like this. These are all these executions that ran. I'm going to go to my execution tab. Then I'm going to click this one, train pipeline. So this is me kind of running the pipeline that we're going to build. And I like the graph view. We can look at it, node view, timeline view, graph view. Then you can click on each of these nodes, and you'll see different tabs like inputs, outputs, task, rerun in debugger. You can actually relaunch the whole workflow from here as well, or individual tasks. So if you want to do a hyperparameter optimization from the UI, or pass this to a domain expert and they want to adjust parameters, but you built the pipeline, you could do that as well. And then let's look at, visualize data. This will have an interesting thing. So this one, you can actually see the inputs tab here has a log of all these inputs, outputs, or it doesn't actually output, sorry, it has inputs. And then we can click on this deck button. We'll build this visualization on our data here in a second, but we can actually embed visualizations, markdown or full HTML directly inside each task. So again, this is really a cool feature for coming back and looking at the lineage of like your whole project, which I said can be really, really important. Any team can benefit from it, but there are specific industries where you really, really want to have precise lineage, and you can kind of debug what was going on. So in this case, we have this download data set, and then that data flows over to this task called visualize data. And then we can hit deck, and we'll see that we have a graph here. This is the distribution of negative and positive labels that we're going to train on. And then we have a positive review and a negative review. So the data set that we're going to use today is a positive negative review data set on IMDb. Again, this could transfer to more complex data and more complex models. But this is an example of a positive review, example of a negative review, and then we do that for our training, our validation, and our test set. So you can plot all those images there, which is pretty nice to see. We have trained model. We can look at view utilization. So we could actually see, did it use the GPU? How much of it? How much memory did it use? So I declared 12 gigabytes of memory. We'd actually want to bring that down, so we're not paying for that 12 every time. It looks like we just need 1 because it's using the GPU memory. And then we're going to download dataset, download the model, train the model, visualize that data, evaluate the model, and then we'll do a predict sentiment kind of thing. I like to throw in a prediction thing in my pipeline sometimes, so I can pass it data maybe like it's never seen before, or just kind of get a gut feel of like what's going on with the predictions. And let's see, did I implement a deck here? Yeah, so in our evaluate model task 2, after it's trained, we can see how it's doing on our evaluation data set. And in this case, they got 86 accuracy, and we have a confusion matrix. And I can talk more about this again as we implement it, but just kind of showing you what we're going to implement for our pipeline. And then we'll also have an app. See if this is, so I'll have to spin back up, and I'll talk about spinning down and spinning up as well. Again, you can spin down to 0. So this app wasn't actually running on any compute, and it took a minute to spin up here because we didn't want to pay for that compute at all when no one's using it. And then it's going to spin up and take a minute. And then so we'll be able to pass in text here. And we'll actually have this whole kind of deployed app. So it'll go from end to end, building a pipeline, to a deployed application with a UI using a large language model. So that's where we're going to build. And my copy is done installing. Hopefully yours is as well. Once that is done, you want to scroll down and hit this union create login serverless auth device flow. You can just run this. You will need your account at this point to be logged in. Let's go configuring the YAML. You'll get this URL. Click on this. This will come up with this little screen here. And then you should be able to click next. Don't change any of the letters there. It takes a second. Device activated. And then I go back and it says login successful to serverless. So now we can run all of our code into Union again, which is managing your whole kind of infrastructure here. Any questions real quick? So I haven't seen anyone post in the chat, which is either a good sign or a bad sign. Were people able to log in? Was there an issue? Did anyone get the kind of onboarding email? Like I mentioned, there was an issue on serverless the other day, or like a small hiccup for sign up. So let me know. I think we're fully recovered from it, but it's hard for me to know if anyone else is having issues. If you are, put in the live chat or join the well, probably best the live chat for now. But you could also potentially post in the Slack channel I had shared earlier in the Union support and put like your GitHub handle, and we could probably get you onboarded. All right, so since anyone hasn't said anything yet about there being an issue, now we're going to go ahead and run the code and build that pipeline. So go ahead and run this command, and then I'll talk about what this command is doing. This is going to kick off your workflow. So you can see we're saying union run remote. And if we remove this remote flag, then it's going to run locally. Since we're not running on a GPU here, we're just going to go ahead and do remote first. But like I had mentioned, being able to debug on smaller models and stuff locally can be really, really important for your pipeline. So you just remove this remote flag, and then this would try to run locally. We're not on the GPU instance, so it would take a long, long time. And then we're saying workflows train pipeline.py. Now, all the code that we downloaded actually lives in this folder that was cloned from the GitHub repo. And you can go look in this workflows folder and see that there's this train pipeline.py. That's what we're referencing there. And then we're calling train pipeline, which is a function. And then we're passing in parameters. In this case, we're saying, look at our data 3 full times. And then the tuning we want to use here is full fine tuning. But we can also pass in a parameter for LoRA and QLoRA. We'll show how to implement those here in a minute. And so you could change this command to LoRA or QLoRA, just like above, all lowercase, if you want to use one of the other methods. And we'll look at this code here in a second. I just want to mention it lives here. You could double click on it. You could see the code that's in here. But what I did to make it easier for the workshop is I also just put the code into a code cell. This write file function is this write file thing is a magic function of Jupyter Notebook, where if you run this, this will take the code that's in here and overwrite that existing file. You don't need to run these code cells, but if you did want to change code, you could do that here and then run this code cell and overwrite, and then you could come back here and rerun this command, and it would run the new version of the code that you did. So to make it easy, put all the code here. This is that train pipeline.py. And we can see we have this workflow decorator. What the workflow decorator does is basically in our workflow here, we're defining the flow of data and tasks with each other. And then each of these little nodes are called tasks. And we'll see we have a task decorator, and that's how we define the compute and all those other parameters that we talked about. But in our workflow one, we just have our train pipeline function. Let me zoom in a little bit more. I think that's good. Let me know if you want more. I think that's a good amount. And then we have parameters in our train pipeline function. Again, like by default, it would be LoRA. What's the model name that we're going to pass in? So you could adjust the different models. If you do this, you might need to adjust the LoRA configuration that we'll see a little bit later in the code. The default number of epochs, again, that you can override when you call this, either in the UI or CLI. And then these are going to be the text we pass in to get a little extra prediction in our pipeline, like I mentioned, kind of make sure that it's functioning. And then this is our flow of data. So we're getting train and validation and test dataset from download dataset task. That's this task. And again, we'll see the code for this in a second. I'm just showing the flow of it first. And then we have our download model. And we're going to pass that model into our train model. Same with those datasets and parameters that we took in. And then we're going to evaluate our model and then do that batch sentiment prediction. So this is how you tie together the flow of data and tasks. Then let's look at the all the other parts of the code. So in each of the, first I'll just mention, so in this case, we have a single pipeline that's like downloading the data. We could do pre-processing to it. We're going to train a model. In larger teams, sometimes you might break this up a little bit. Like you might have a whole separate data team that does like data engineering and then makes that available for you to pull into train. And then you might have a training team, and then you might have like an evaluation and or the kind of shipping model team. So today we're building kind of one workflow, but you could have multiple workflows and kind of combine them together if you wanted to. So the complexity can scale to wherever you need to for your company. Here we have containers.py. Again, you can navigate this, or if you look in the GitHub, you'll see that there's these code files. So this is going to be containers.py. And this is where I'm using the feature that's built into Flight and Union, where I'd mentioned that you don't need to write Docker files. You can actually just use this thing called image spec. So here we're defining a container image from image spec, give it a name. In this case, I'm calling it Finetune QLoRA. Then we're saying, basically look at the requirements.txt, pull in all those packages. We'll see those packages in a second. You can pass in extra parameters like, do you want to download from a specific CUDA version if you can. The builder's on Union, so this means it's going to look at these requirements and then build this on Union, so you don't have to have Docker even installed locally if you want to build this container remotely. Specific types of CUDA versions, so CUDA is like the driver library for usually doing deep learning with NVIDIA GPUs. And then you can also install other packages like this. In this case, it's a C++ builder because we're doing quantization. But you can do really any type of environment setup just directly in your Python code without having to write a Docker file. So I don't know, does anyone love writing Docker files? Or do you like writing Python, and does this look interesting? I think it's a cool feature. I haven't, it's been a while since I've written a Docker file. Actually, I usually use this now, which is kind of fun. We'll see this in action later, but we have something called actors. So if you are kind of newer to container development or Kubernetes, it's interesting because like when you spin up the container and compute to run this task, it spins up, and then when it's done, it spins down. So you need to think, how do you like pass data out of it? Every single one of these is going to spin up again and take time potentially for that. So if you downloaded a really large data set and you did something to it, and then you need to pass that off to another task, but you still want the reproducibility kind of stuff of containers, we have a feature called actors in Union, which is a long-running stateful container. So you can say like stay alive for this amount of time, and then you can use that container reference between different tasks. We'll see this a little bit later on. I'm not going to go too deep into it now, but it's kind of a bonus feature that we'll see at the end if you're interested in seeing more about it. But it's a cool feature that people really seem to like for efficiency and yeah, being able to reuse containers with like massive data sets is something that I see that people really like that feature for. Then these are the libraries we're going to use: Torch, Transformers, Dataset, Parameter Efficient Fine Tuning, PEFT, Bits and Bytes, Accelerate, Flight Kit, Union, Python.env. This is actually when I was doing something locally, so we probably won't really see in action today. Matplotlib, Pandas, Scikit-learn, and Seaborn for some visualization here. And again, we'll see these kind of as we go. Also, there's a fair amount of code. So I'm going to go through what I think are the important parts, but feel free to ask questions in the chat. Like, hopefully I'm not going to skip over too much. You have access to all the code. Hopefully you even have it up and are looking at it right now. But if you have questions, let me know in the chat and I can kind of come back to it. So I'll go through stuff as we use it versus covering all the imports. Here we're defining artifact specifications. So inside Union, we can define what's called an artifact. So this could be models, data sets, anything that a task might produce. And this is really a handy way to kind of just reference it. There's different ways of getting this. So like if we run this pipeline and this one outputs 3 data sets. So it has the train, validation, and test data set. And we could actually reference these in different ways in the Python like SDK. Like you could look at outputs of node 1, pull in this 0, 1, 0, 0, 0, 2, and pull in the reference to these artifacts. So basically when they get passed out of this task, they get written to a blob storage somewhere. And you could do that with artifacts. It makes it a little bit more seamless. There's this artifact tab. Everything gets a version. So I just reran this. You can see I have this fine-tuned IMDb model. I can click on this. I could add more information into a card. Like actually a good thing to add here would be like the evaluation metrics, like the accuracy and stuff on specific data. But what's handy is I can always click on this lineage tab. And if this is used in other workflows, I can see that here. But I can actually click back to the original workflow that produced it. And then it'll bring me back to this whole version. And then I could go into the evaluate model, see what the metrics were here, and then actually kind of look at the entire pipeline if I wanted to. So there's really cool kind of baked in lineage stuff with artifacts, and we set them up this way in the code. You import artifact from Union, give it a name, and then give it a variable name, and then we'll use that when we pass it out of a task to create that thing in the UI that we just saw. And we'll use it later. It also makes it really easy to query down to other workflows or when we serve our application. And every single artifact is version. So when we rerun this workflow, you get another version of it. And then you can just call like .query to get the latest one or pass in a specific hash number and then pull in any ones that you wanted to in the past. So our first task that we're going to implement, again, going back to the execution view, is the download data set. And then we're going to do the visualize data. So this is kind of the interesting part maybe you haven't seen before. As we're writing our Python function, again, we enforce strong typing right now, and you could do this with other libraries as well, like MyPy, like I mentioned. So we're saying the output of this has to be a tuple, and then we're passing out that annotated version, which creates the artifact. And annotate is actually a typing in Python where you can pass out a piece of data and then tie metadata to it. And flight file is a specific thing to flight. You also see flight directory. That's just a way of passing out that data and then writing it to the blob storage, so that you can reference it again between all those other tasks, like I said, after they spin down. So on top of that, we add in this decorator. We're saying container image is equal to container image, and that's what we defined up above in containers.py. So this is getting that requirements.txt. It's getting specific versions of CUDA, any other packages. Now it built this kind of Docker container, and then we're importing it here just from that .py file. And then we can use it for all of our tasks. And today we're just going to use one container for all the tasks, but you could have separate containers, like a lighter weight one for the downloading data, the heavier weight one with the transformers library, if you really want to optimize for other spin up speeds. And then we're saying caching is equal to true. So if I go back to this, we talked about caching in the slides. We can see that when I reran this workflow, it actually says output for this execution was read from cache. So anytime I rerun the workflow, the first time you run it, it'll say that it wrote to cache. Anytime you rerun it after, it's going to read it from cache. So when we rerun this, it's actually not going to run these download dataset or download model until we either take away this cache equal true or give it a different cache version here. And then so when we rerun the workflow, we're not wasting time or resources doing these tasks that we don't want to redo. And then we are loading in our IMDb dataset from Hugging Face. And then we're basically splitting it on train and test. And then we want to get one more data set. So it's pretty common in deep learning to have training data set, validation data set, and testing data set. The training is what the model looks at when it's learning. Validation is you can look at metrics from the model while it's learning to get an idea that it's going in the right place and change hyperparameters. And then you have a holdout test data set that you don't use during the training phase, and you look at that data after you've trained your model to see that if it's performing pretty well in there. So we want to get one extra data set to create the test one, or create the validation one. So here we're splitting our training data on with 20% of the data going to the validation data frame now. And we're doing it on the label, and then the random state is just set to 42. And then basically we're just saving all these CSVs, and then we are writing them out as artifacts. So now we can reference these into other workflows as we go, and which we'll see in a little bit, but also we can just, it's being returned as a data type so that when we defined our workflow, we're actually just passing in that data again in the other workflow function that we saw. And some of this goes to visualize data, some of it goes to train data. And we have our visualize data task, which is again taking a container image. One new thing here is enable deck. That's what allows us to get the cool baked in visualization into our task here. So again, we could put anything here in Markdown or HTML, whatever you want. I think it's really, really cool and really powerful way of documenting your data. And like anything else, like I actually didn't implement it here, but for like training epics and seeing the loss and accuracy as you're training, that's really cool as well. One thing, if you don't already do this, I always recommend reading in your data set. Depending on the type of your data, it can be messed up even more or easily. In my experience, like computer vision, images get read in wrong all the time, or annotations to them get read in wrong all the time. So I always like to have in my pipeline some way of visualizing the data just to make sure that it read in the thing I wanted to. So again, this is just showing us distribution of our training, validation, and test class, and then also showing us one of each of the types of reviews here. So I always like to have something where I can double check my data while it's training. Like if I'm not getting the results I wanted, I can go back and reference this and see what did my data actually look like. And again, we're requesting resources. This is just 2 CPUs, 2 gigabytes of memory. We'll use a GPU for the training later, which we'll see. And then we just have our visualize data function. It's taking in those data sets, basically just downloading those data sets. We're getting the first positive and negative review from each one of them. And then this is just creating a plotly plot that gives us that visualization that we saw. We're just saving those. They get converted to base64, so they can just be written directly into HTML. And then this is just the HTML report here. It's just an F string in Python that gets converted to HTML, and then we're passing in those parameters and stuff that we had created, or scores, or in this case, just the positive review, but it could be any value you want in Python embedded into HTML. And then we're initializing our deck. We gave it a tab name of data analysis, appending that report to it, and then we insert it to tab 0. So when we open this up, we can see it says data analysis. It's in tab 0 here. You always get these other pre-built ones here, like the timeline. What was it doing at what time? The source code. So again, everything is versioned, the input, the output, the whole code, everything in the workflow automatically, which is really, really useful. You can see the exact dependencies that it used in the container, and you see the input and the output. So this is the inputs that were passed in, and then we didn't have an output for the task. So you can see that all in the deck automatically as well, which is nice. Now we go into the task/models.py. And again, if you look at the code on GitHub or you're setting this up locally, this is going to live under the task folder. I broke it down into data tasks, model tasks, and then there's some inference ones that we might look at later if we have time. You could break this up into any structure that you want, though. So if you like writing them all in one file, or you actually want to write everything in a notebook, you actually can do a version of this without even writing .py files and just run it from a notebook. But I structured this as like more of an ML project that I would actually write. But if you wanted to, you could actually write and run production workflows directly in notebook cells, which is kind of really cool if you think about it. I like structuring like this, though. So then I have my task model.py. Again, we'll talk about imports as we go. We're defining another artifact. This is the fine-tune model, so we can easily query this down into our app when we serve it. And then we have our first one, download model. This is very similar to our download data task for parameters here. Again, just pretty lightweight resources that we're requesting. So again, every time we run a task, it spins up with these resources and this container. And then this is going to be cached. So when we rerun the workflow, it's not going to spin this up when we don't need it, though. It's going to be outputted as a flight directory. And then we are just giving it a directory to save to, which is saved models. This is how we're getting the model from Hugging Face. And this is one thing that you would change if you're using a different type of model. So we're using a sequence classification model, the BERT model today, but you could do auto model for causal LM or causal LM, I believe is what you put here. And then you would pass in, like, if you want a DeepSeek or a Quint3 or something like that. I have some examples that you can look at for this as well. But this specific thing is what you want to change out for different types of models. Because right now we're passing that distill BERT string, and it's going to take that as a name, pull it down. I'm just going to pull it down on CPU. And then we're going to get the tokenizer in the same way. The tokenizer, if you're not familiar, we won't go too deep into it, but it's basically the way that that specific model breaks up text to read it in. So every model has some form of tokenizer that it uses, and they can be broken up in different ways. So some tokenizers, like you might have seen, like an example, if you have a string of like hello world, it could break up every single character. That could be a token. Each word could be a token. But what most of them actually do is they break up on partial words that make up other words, and then that increases the efficiency of the tokenizer or of the token usage. So you can look at different tokenizers, but we're just using the one that comes with our BERT model here. And then we're saving the model and tokenizer and outputting them into a flight directory that we can, again, reference this later in our training task down here. Here, we are referencing a container image again, just like we have. And then here, we're adding way more resources. So we had 4 CPUs, 12 gigabytes of memory. We actually saw that when I looked at the utilization for this, if you were here at the beginning or a little bit ago, inside of the workflow, that actually declared too much memory, and I could probably bring this down. I'm not going to worry about it right now. And then we are declaring 1 GPU. When you set up Union or Flight on your own cloud, you can configure what the default GPU type is. On serverless, it is a L4, I believe, or a T4, basically a lighter weight NVIDIA GPU that's still pretty powerful. But we also have A100s in the serverless cluster. So actually, if you're using this to build more complex models or something like that, you can actually access A100s with that $30 of cloud credit as well, which is pretty neat. And there's a way, we'll actually see it later, that you can overwrite like the default and then declare a specific type. So we'll see this actually when we deploy our app. I'll show you how to bring that in. But you basically just import a type and then say accelerators equal to A100 or T4. You have our train model function, taking in our data directories, passing in the default epic amount. Again, then we can overwrite any of those when we call it. So again, it's going to look at our data set 3 times by default. And I think that's actually what we ended up using when we did call it as well. And then it's going to be, again, a string for, are we going to do full fine tuning, LoRA or QLoRA? When the function implements all of these, and then it just takes in a string to understand what to run in here. And then LoRA, these are some parameters that go into it. We had talked about the, bring up the slide real quick, actually. Basically is making a smaller matrix that you're going to train in between your full weights. So this 8 is the rank 8 is this parameter where you're basically going to downsize the matrix to that. So it has to be the same size on one side of the weights coming in, and you can downsize in the middle, connect to the output weight. Basically, are creating 2 weights here that are connected to each other, and then it needs to upscale again to whatever the fully connected weight is out there. So we're passing an 8 here, so it's going to go by the 8 by whatever inside of our matrix. You can adjust this. This is a hyperparameter that can increase or decrease your accuracy, for example, in this case, if you're using the LoRA or QLoRA. It's common to start with 8 and then adjust from there. And then it's common to start with 16 for the alpha. This is basically the importance that then the network tries to get from the weights. So this is a number, again, you can adjust around as well. And we have dropout, so it can drop out some of the weights to try not to overfit on the data as well. So all different parameters you can play around with and see what's going to work for your model and data. So if you don't have a ton of data, you might be playing around with these quite a bit. Same with like the number of epochs that your model is going to look at. I mean, what I found too, at least for the classification type is that you often might need more epochs because if you're not updating the full weights, it's not learning as much about your data usually. So at least for the classification tasks, if you're using conversational language models, it might be a little bit different here. But for the classification, you might want to up your epochs a lot, and then you'll get more similar score to full fine tuning of 3. You might need like 10 or something like that, and it might perform pretty well. So just keep that in mind as you're taking this and maybe implementing it somewhere else. QLoRA that was passed in here. If so, then we want to do this bits and bytes config. So we just imported bits and bytes. Again, it's actually really cool. These libraries are incredible. They make it really easy to do these really advanced concepts, where now we're just doing bits and bytes config. We say we want it in 4-bit, which is usually most stuff comes in like a 32-bit. So we're condensing it down quite a bit to a 4-bit. The quantization type. What does NF stand for again? It's is it near float? Basically, it's a more, I don't know if it's near float. I forget the N and NF. Someone else can let me know if you happen to know, but it's basically a more efficient version of a float that you can use. And then double quant is the way it quantizes it down to 8 and then 4. And then this is an important thing to think about is the way we're doing this, because we're not training a quantized version of the model to use the quantized version of the model. We're using QLoRA, which is where we're loading in a quantized version of the model. But we want to train it, but then we want to merge the classifier and pre-classifier layers. These are what our model uses to make those predictions. We want to merge these weights back into our original size model. So we actually want to skip these, don't quantize them. We're going to quantize the whole model. And then as we're learning, we're going to update these things. They're important for our model to learn from. But we don't want them to be quantized when it's learning. So we want these weights to stay the same size, and then we merge them back into our original weight. They should still work. And then if it's QLoRA, we're going to set up that config and then pass in that config to our load model, which is going to load in that model that we had downloaded before. And then else it's going to look and see. Otherwise, just load in the model normally. And then it's going to look to see if LoRA or QLoRA was in there. Then do this next step, which is now we're importing the parameter efficient fine tuning library from Hugging Face. We're going to set up the LoRA config. So the type is sequence classification. These are those numbers we talked about, basically just setting LoRA R, LoRA alpha, dropout, and then these are the target modules, the query, key, and value is what they stand for. These are typically things you're going to want to inject the matrices onto. For most LLMs, again, it's something you could experiment with. And then also just noting that if you are using a different type of model and you want to implement LoRA, QLoRA like this on them, these actually might be called something different in the model, even though they're probably a query key value. They just might not have this exact stream to target them. They might have the whole word key or something like that. So you might want to look that up for the different type of model that you're bringing down if it's not this distilled version. And then we're going to load in the model with that LoRA config. Otherwise, if it's not, then we're not going to do this whole thing, and it's just already loaded in the model normally above here. We're not going to apply the LoRA config to it. Then we go to the training part. So we're setting up the training arguments. Like the size of samples we're going to read in every epoch, where it's going to log everything. It's going to eval on the loss here. There's also some other stuff that we didn't implement here that's really cool to think about. Like if you haven't looked at early stopping, that's something where, let's say you said, go train for 10 epochs, and it's going to try to look at the data set 10 times. But really after 3, it hasn't improved at all. In fact, maybe it's overfitting and getting worse on the validation data. So you could say, if the validation score doesn't improve over the next 2 epochs, then stop training and then just give me the best version of the model that you saw. So there's some other really cool stuff we could implement here that you don't see right now. Then we're just going to call trainer, pass in the model, pass in the training arguments, the tokenizer, the train data set, the evaluation data set after they're tokenized, and then our model is going to start training when we call it trainer.train. And then when it's done, there's different ways of doing this. What we're doing today is we're just taking the LoRA weights as they got updated, and then we're just going to merge them into our large model and then save it. What you can do, though, that's kind of a cool method, is basically you get these weights from LoRA or QLoRA, and you could save those separately. So we could actually save them as artifacts, and then you could have a version of this model without them, and then you can inject that LoRA in by calling this somewhere else, like when you load in the model. And you could actually then have different versions of your LoRA weights and inject those in whenever you wanted to that type of model. So there's some really cool stuff you can do with LoRA configs if you want to experiment with like changing them out or something like that in production. Today, we're just merging them in and then saving a version of that model. We're just doing that at an output directory. And then we call this is the artifact we defined above, create from that artifact. And then it's going to pass in the output directory. And we're going to have the artifact that we can then pull into other workflows. And then we'll serve here in a little bit. And our next workflow, or sorry, next task in the workflow is evaluating the model. So stuff we've already seen, container image, enabling the deck. We do need a GPU again because we want to load in our model where we can actually run predictions on data that we're going to pass in. Download the model and data locally, kind of like we did already before, except for this time we're doing the test data frame, not the train. And then we're setting up this little NLP pipeline that's built into Hugging Face. So we're saying it's going to be text classification, passing the model, passing in the tokenizer. I forget why I comment. Oh, I think by default it's going to the GPU. I didn't need to set it here. And then we're going to call prediction, pass in text, and that's going to be a text from the test data set. And then we're going to basically see if it predicted yes, or sorry, true, sorry, positive or negative. And then we're going to output some classification metrics like accuracy, F1, precision, and recall. And then we're going to create the deck, create a confusion matrix. I'll talk about this in a second. We'll go look at it again. But basically, we're just creating another HTML report, appending it to the deck. So then if I go back to my workflow and I open up the evaluate model, and I go to deck, this is what we created. So down here, we could format this better if we wanted to, but I just have this JSON here saying the accuracy of our model is 86% on our test data set. F1 was 85, precision was 87, recall was 86. And then we have a confusion matrix, which is kind of a neat way, if you haven't seen one before, of looking at classification metrics and seeing how well it did on each class. So we can see for class 1, which I think was positive, or maybe I'll have to go look, maybe that was negative. It only got 2 wrong. 2 positive ones ended up down there. For this other class, or sorry, for class 0, then it got 12 wrong here. That should have been in the other prediction. Should have been in the positive, not negative one. So it's a good way of seeing like what your model does better on, especially if more than just 2 classes. This could be really interesting to kind of see like this heat matrix of how it performs on different classes. So if you ran all the code, we did that, and you should have a pipeline that probably looks like this. It probably should be done running. Again, you can go click in everywhere, hit that view utilization. I think this is really helpful to pull down those resources and again, make your pipeline more efficient. Like again, we could bring down CPUs to just 1 and memory to just 1 because everything actually ends up running on the GPU. And again, we're not paying much for that out of our credit. But if you're doing this a ton of times, it would make sense. So you should have something that looks like that if you were following along. If you want to rerun, again, you could relaunch directly in the UI here. You could also set up schedulers. So if you wanted to run a data pipeline at a specific time every day, or when something else happens, like a file change happens or a folder or a file gets added to a folder, you want to process that data, you can add a trigger as well for your launch plans. So now, though, we have our trained model. If you go to artifacts, you should have something that looks like this, Finetune IMDB model. Click on it. And then again, we didn't add information. We should add stuff to the card here. I'll probably add that in later. But you can go to lineage and click back on where the workflow generated that model. So now that we have our model, let's serve it in an application. Again, let me know if you have any questions. I see people here, but the chat's been kind of quiet, which again, it could be a really good sign that there's no problems or questions. But if you have questions, let me know in the chat. I'm going to keep going for this serving part, and then I'll probably pause. There's a little bit more we could go into if people are interested, but this will be kind of the main next part that might be interesting for people. So we have our model. Now we want to serve it in an application and actually be able to use it like I had showed earlier. So if you go back to the notebook, we have this serving the Finetune BERT model section. You can scroll down. Again, all the code lives here. We're just going to run it in the code cell though. So you can hit this union deploy apps app.py BERT sentiment analysis. So go ahead and click run. Again, these are in the folder icon, or if you're in GitHub, you can see all the .py files. But again, I have them in the code cell, so we don't have to open up or navigate different files just to show them here. So this is running. Oh, and something I should mention is even when you ran the workflow, Mine started running and generated a URL for the workflow. And it says like image already found for this skip building. First time you ran it, it didn't find that image. So it actually had to go ahead and build that image. So it probably took like a few minutes longer to run than mine did because it had to build the image first. And then it pulls that image down to the task like we just saw in the code. So now we have our app.py. And basically, we have a cool way, kind of like we already saw for defining your pipeline infrastructure, a way to define your serving infrastructure. So here we're using something called image spec. We've already seen this, but I have it directly in the code here instead of looking at the requirements.txt and passing in some other packages like Streamlit here that we didn't use for our pipeline. Again, builder is going to build on Union. And then we have our Streamlit app is what we're calling this. But basically, this is a Union app first that we're defining. We give it a name, give it inputs. In this case, it's going to be that BERT model. And it's going to call that artifact that we created, .query, like I mentioned, is actually going to pull down the latest version of the model. But you can also pass in specific hash versions. So if you want to roll back, it makes it really easy. Again, like every time you ran that workflow, you're going to get a different version of that model. And you can roll back or pull down different models very easily. .query just always pulls in the latest one available. It's going to download it when the container spins up. Pass in the container image like you've seen before. And then again, this is similar to like we've seen before when we defined the workflow. But now we're just doing it for an app serving. So we say the amount of CPUs, the amount of memory, the amount of GPUs that we want, the amount of ephemeral storage. So again, this is going to spin up a container. Then when it's not being used anymore, depending on how we define the other parameters down below, then it's going to spin down. And then this isn't going to be available to us until we make it available again. So here also, I mentioned that we can define specific accelerator types. We just imported L4 from Union. And by default, it is an L4 in serverless. But you could import like A100 and change the accelerator type to that if you wanted. We're saying what port our app is going to run on. We're also going to include main.py. So main.py actually has the Streamlit code. This is just the infrastructure code setting up what our application looks like. The arguments to make our app run. And then this is the really important kind of cool scaling metrics that, again, you just define this all in Python without ever having to leave your project, which is really, really neat. We have min replicas and max replicas. So min replicas is set at 0. And then we have the scale down after value here. So what this means is after 5 minutes, it's going to go scale down to the min replicas. In our case, it's 0. So we're not paying for any compute when no one's using our app. But that means that when someone visits the URL that our app is at, it's going to take like a minute to spin up. Sometimes if you have a really large model, it could take more than a minute. So you want to think about like if you actually have users that could be impacted by that, you would have this min replica set to like 1 or 2 or something like that. So you'd always have a container running, but then you have to pay for that compute. So min 0 is really nice. And if you're actually building an application like this for internal use, you might be totally okay with it. But if you're building something for customers that you know that's going to make them churn or something to think about. And then you have max replicas. In this case, it's just 1, but you can set this to much higher. And basically, you have the scaling metric saying if more than 2 users were here, I should actually probably set this to 2 or something. If more than 2 users are at my URL, then spin up another replica to help handle that traffic. And then by default, your URL is not going to be public. You have to be authenticated into your Union account. And Union serverless is just a single seat thing, but the enterprise one is not. So like you can have role-based access and multiple users, and then so they could be authenticated and go to that URL. Again, if it's like an internal application, which something we've seen people actually use this for. But you can also set requires auth to false. So if you uncomment this out, then your URL will be public, and you could share this with your friends or a portfolio piece or something like that if you want to today. You could just uncomment this and rerun this code cell and then rerun the deployment, and then your app will be public. So then this is our Streamlit app code. Basically, we're trying to load in that BERT model, making sure it exists. Then we'll see in the Streamlit app, we're just setting title, text, taking in user input that's going to be at this window height of 400. And then we have this button that we call analyze, and then basically just changing the color and label to positive or negative depending on the value that comes in. And then we get this output. So if we go back here, let's see, I should be spun up already, but maybe I'm not. No, I think I had to spin up again because it was over 5 minutes since I had used it. All right, so again, I'll just say I love this, but we'll find a more complex thing here in a second. And it says predicted sentiment positive. It's pretty sure. I hate this. Obviously, this is probably going to be negative. Now let's go find a much more complex movie review and see what happens. What's a movie that I should select from? And well, people are thinking of that movie. I'm just going to grab a sip of water or coffee. No, water. Water sounds good. All right. No one said a movie. I'll go in and I like to get one that I know there's going to be some bad reviews for too. So I'm surprised the Ballerina has such a high score, user high score, which is fun. So let's get, I don't know what this movie is. I haven't actually heard of it, but let's go look at audience reviews. Usually get a mix in here. Let's see. Okay, so let's take first this good one. And let's pass this in. So it's kind of fun if you were following along. Try this on. I saw someone said Thor: Love and Thunder. I'll go get that next. Since I'm right here, I'll take this positive review, paste it in, and you can try this on anything you want. So, and again, our data set was only trained on IMDb. And I actually think I forgot to mention this, but in the first, let's hit analyze. So it's a 94% confident that this is a positive review, which it was when you looked at it. That's a 5-star review. This one's going to be hard because this is a 2.5, which isn't super negative. Let's see what our model thinks. And again, it wasn't trained on getting stars or variations. It's just good or bad. And so we'll see what it says here. And then one thing in the code is, because it thinks this is positive. One thing in the code, like I mentioned, I think I forgot to call it out when we did training. So one, we only looked at our data set 3 times, but also in our training, we loaded in the data set. Where is it? We only took like 500 samples because if we trained on the full thing, it would take a lot longer during the workshop. Okay, yeah. So you can update this. I forgot to call this out. I set this as a parameter probably too. They can pass in the function. So this took 500 samples from, I think it's like a 50,000 data set. So if we use the whole data set, we'd probably get more accurate results, but it would take a lot longer to train during the workshop. So I wanted to get something that could get us pretty good results pretty quickly. And then we're just validating on 100 as well. So you can update this number to be a higher number or get rid of this sample piece altogether and would take in the full data set. Just keep in mind, it would take a lot more time to train the model and more resources. And again, this is kind of hard because our model, this isn't like a 1-star awful review. Let's see this one, a 1-star, half-star. And also, we use the IMDb data set, and the reviews there might look very different than the reviews here. And most of them, I think, were longer in the data set. So really, the data stuff is really, really important. This one, it gets as negative. Thinking about the data is really important when you're training your model. But also just we use this pretty small data set for the example today, and we only looked at it a few times. So we could do a better job of training our model. This is just an example for you to get started. So someone said Thor, Love and Thunder. Let's look at that. What did you think about Thor, Love and Thunder? What would your review be? Audience reviews. I'm sure it's going to guess this one. This is genuinely horrendous. Let's see. Analyze. Very confident that's a terrible review. Let's look at this one. This will be interesting because it's 3.5. So it's not so good as 3 and not so bad as 2. But this will be hard because it's got a lot of the word bad in it. And our model might have kind of overtuned on that word. But no, look, it's actually positive. So pretty cool. So again, the BERT models are really good at stuff like this, like classification with pretty lightweight parameters that, again, if you were going to run, like if you had thousands of these reviews coming in, but you didn't want to pay for the GPT call for every single text message or something like that, BERT models are really good. Also, sometimes you want to host your own model, or you have to host your own model on your own infrastructure. Like if you're in healthcare and you can't pass data some places, etc. You can use this kind of lightweight model and get really, really good results. So like I said, it's actually not uncommon when I talk to companies that aren't tech companies, like what they're implementing. A BERT model comes up quite a bit actually right now. Well, what did people think? Was this interesting? If you were following along, you actually, like, even though we went pretty fast and like some of these concepts might be new and maybe it was like maybe you felt overwhelmed in parts of it. That's totally fine. You have all this code. You were able to actually run it, hopefully, and you actually went and built a modern pipeline with a lot of best practices like caching, versioning, resource containerization, and management. And you were able to deploy an application that can actually, you can go adjust those scaling metrics, and you deployed it in a way where it could scale if you wanted it to. What did people think about going kind of through that whole process? Was it interesting? Was there anything you didn't like? And what would you want to see next? I'm actually working on some other projects to show off in like workshops and blog posts. What type of examples would you want to see? So, for example, like this is a classification one, working on some conversational LLMs, and I actually have some examples that you can go look at if you want to run those. Actually, let me pull up one to share that people might find interesting. And then I'll also agent, RAG applications. What are people interested in seeing more of? And then also, yeah, did you like this? Was this interesting? You see kind of the value in some of the stuff here? Let me know in the chat. So I have this repo I'll share in the chat as well. This is has like 3 examples in there. So it just focuses on the serving, not the building the pipeline thing. But if you thought this was interesting, you can actually go. I wonder if I have the app still saved. I might be able to just serve it and show an example. Let's see, Gradio chat. Let's see if this works still. I might have to update this app. And then also, what's this? I forget what I named it. I did bad naming convention, so we'll see. But I shared in the chat. If you want to basically build or like build UIs around different types of models, there's like 3 examples in that repo that you can follow along on in the GitHub notebook or the Colab notebook, kind of like we already saw today. Let me see, because I forget what I actually call this one. Okay, Gradio chat. So it might spin up. I might need to rerun these workflows to re-download the models potentially. But awesome. So Hannibal said, can you show us an agentic workflows? Definitely coming very, very soon. Keep an eye out. I've been playing around a lot with different agent frameworks and stuff. Curious what people have, or if people have opinions on agents and frameworks they've been playing around with. But yeah, that's coming very soon. We actually have some really, really cool features coming out very soon. I can't quite talk about them yet, but around agents. So you can already build agents in here in various different ways. I could have agentic workflows, get all the versioning, caching, stuff like that. That's pretty interesting. But we're gonna have some cool new features around that I'll be able to show off, I think, either later this month or next month. But you could also serve models here and then use those in agent framework, or have the agent whole agent workflow kind of served as an app. And like I was saying, I think I might need to potentially, I need to I won't show these right now because I have to re-download the model that's not here anymore, and that's why it's not spinning up, because I made these a while ago. Basically need to re-download the artifacts here, but I will build some stuff around that, so definitely stay tuned. But we'll be able to build some cool like interfaces. I actually see if I have something more recent that I might be able to show. Oh, let's see if this loads. And again, this is something I was experimenting around. Might not be in a fully great state to show off in like a workshop yet, but it will be soon. This is a RAG application. Let me see if this spins up. Again, like I was saying, the artifact, I might need to re-download the model here. And someone said, awesome, they enjoyed at the workshop. Awesome. Yeah, thank you for coming. And again, if you have questions later, join the Slack channel. And that's also where I will be posting more stuff around like the content, the agent content, for example. And I think we're going to be planning some really cool events that can allow you to kind of build something and show off what you're building, but hopefully in a fun community way. I'm excited to do that soon. And this one, before I show it in workshop, the vector database is pretty big. That's why I need to make a smaller here, because we're also just hosting the vector database in the app, which is not the most efficient way. I mean, it's a way of doing it, and it can totally work depending on what you're trying to do. But I was using a Weavy embedded, which is so you can run it in your compute environment. And I used a really big data set, which I wouldn't do for the actual workshop probably. Again, like I said, I use smaller samples for training. I would do that in a RAG application too to make this part kind of faster. But also this would go really fast if we actually use like Weavy hosted and then are just loading in a Hugging Face model, which is also what it's loading in. So we'll see if this loads here in a minute while people are waiting around. But any other questions while I'm still here? Otherwise, we'll probably wrap up pretty soon here. Did anyone go through and actually get to the point of having their app deployed? One thing to note too is you get useful information like logs and stuff all in the UI as well. Same with in our executions, actually. So if we went back to our train task, we looked at the view utilization, but you can also view your task logs. So as this is running, you can view outputs and stuff like that. So really easy to kind of debug your code in the console as well. Also, didn't mention we have workspaces. So if you want to run a notebook, or really you just get VS Code in here, so it could be .py files as well, but you want to run it on a GPU, either simulating a container or just because you want those resources, you can set that up in here too. I've had some customers actually use this too to kind of simulate lower resources, which I thought was interesting. So they'll set up like a one CPU or something like that, trying to simulate a little bit more being on like an edge device. I thought that was actually a cool use case I hadn't thought of. Okay, cool. So my RAG app, I think, actually started. So this is an example. I'll probably do a workshop on building this. This code might be on the Union OSS GitHub. If not, it will be soon. Basically, if you're familiar with RAG, there's just a vector database here they made with Weavy embed, and it was based on medical. It was like a medical journal thing. It was a biomedical question journal. And I'm not a bio person, so I actually have really bad questions to ask here right now because I don't remember what all the journals were about, but I'll say something like symptoms. Really bad at spelling here. And then I can adjust in this slider, basically how many context chunks to pull in from the RAG database. And then I have a little box here to show those chunks, and then I'll hit submit. And then one thing to note is I'm also using a really bad lightweight LM, so we're not going to get a really, really good answer probably here because it was like the T5 Flan Google one from a while ago, and we could actually use like Quinn 3 or DeepSeek or something here, Gemma, and get a better answer. But basically, it's a Gradio application, which is another UI thing, kind of like Streamlit. And then we can see that we said pull in 4 context chunks from our vector database, and it did right here. Shows them all, and then we get the answer that our LM produced from combining the results here. And again, we're using a kind of a very lightweight LM that isn't going to give us the best answer, but kind of cool. Someone said waiting for build to finish. Is that waiting for the waiting for the build to finish? Oh yeah. So I had mentioned that if you're running this, I forgot to mention as I was running it, that when I run these, it basically says skipping build because my container images, I've already run this before, like getting ready for the workshop. So I didn't have to build them, but for you have to build them again. Any other questions? Oh, we did have kind of a bonus thing. Like I'll go through really, really quick on this. Scroll the way down. So this is kind of the optional bonus thing here where we talked about the actors, which is a long-running stateful container. And this is really nice if you're running like batch inference workflows. You don't need like a live inference app or anything like that, but you want to pass up data. basically run it in a workflow pipeline and get results back on it, but you're okay with it taking like a little bit of time. Or actually, as we'll see here, doesn't have to take that much time. But basically, let's just run this code cell. It's going to register the workflows batch inference.py, and we'll look at that in the code cell here again, but it lives in the workflows batch inference.py if you want to look at the code file. This is the same as above when we looked at containers.py. And what we're doing is now we're actually going to use the actor environment. We set it to live for, what is this, 3 minutes, 4-ish minutes. Basically, this means 360 seconds. This should be just 4 minutes or whatever. Basically, we give it a time to life, and every time we query it, it's going to reset that time to life. And then when no one is using it after the amount of seconds that we define, then it'll spin down that container, so we're not paying for that compute. But it's nice to be able to have a long-running stateful container for different things. Like I mentioned, you could use that container around in different parts of your workflow. If you had a really large data set and you don't want to download it or do any prep on another container, that can save a lot of time. But also, if you know you're going to be calling a workflow a lot or a task a lot several different times, you can use this as well, and it doesn't have to spin up every single time. So we'll look at a quick comparison. We're going to use union remote, which is the SDK part where we can basically do anything that we saw in the UI. You can kind of do in the SDK or API. Here we have our predict container, predict with a normal container. We're going to pass in text, and it's going to do a prediction. So if I run this, it's going to kick off a workflow, which our workflow is just going to be a single task in this case. So we're passing in this text. I love this movie. I hate this movie. And then if we look at our console back in executions, we can actually see that it's being kicked off right now. It shouldn't take too long to run, but it has to spin up a container here. And then it's going to give us the outputs of the prediction. So let's see, it's going to take like a minute or something like that. We can see it provisioned the GPU, pulled it in. And sometimes it takes up to a minute or so. While that's going, let me go through the other code. So here we're going to define our predictor with actors instead of a normal container. Same thing as before, but we're just calling in this specific workflow now with the actor container. And if I didn't show you the code there, I'll show it to you in a minute. Basically, run this, or it's still waiting for this. So we can run this code, and when it's done running, it'll run these code cells. And then we're going to run these all in quick succession. So we'll see that the first one still might take a little bit to spin up. Once the containers spin up, all these other ones after it will take like milliseconds or a second to run. So a really neat way of kind of, if you know you're going to reuse a task over and over, you can have this long-running stateful container. And again, it can save you a lot of time. And yeah, I would say time is a big one for this. So again, with MLOps and stuff, it's really interesting. There's a lot of, again, they might sound like small things, but they can really, really save a ton of time and add a lot of efficiency to your pipeline. So this first one on regular container is done running. We see the outputs for the labels, just like we did for, it's using the same model before. It's just running a inference now in the task. And if I go back to the execution tab, it actually says it took 58 seconds for that first container to spin up and give us a prediction. Again, fairly lightweight model here, but we could have a much bigger model. Let's say it took like 5 minutes to load in every single time. Maybe that would be, a lot if we're going to do 1,000 requests, but we only need to do those 1,000 requests like once in a while, or we only need to do it at a specific time or something like that. So you don't want to basically pay for a model to be hosted all the time. You only want it when you need it. So here, now we're running the actor batch inference. The first one's going to take just as long, about a minute or probably to spin up. Sometimes spinning up containers varies a little bit, like within minutes. So the first one's going to take a little bit of time. And then after that, all the calls to that container should be really, really quick. Almost double the amount of time. Like I was saying, sometimes there's some variance in the container speed, like within a minute or two. And while we're waiting for that too, and I know there's still people hanging out here, what's everyone working on or learning? Like what's yeah, what are your like goals right now, or what are you building? It's always fun to hear about like what people are doing and why you're interested in learning more about, LMs or pipelines or any combination of the above. It could just be a fun side project even that you want to share, or that what is the thing that you want to learn next. Oh, let me see. I think these are running. Okay, yeah. So the container built here with our actor, and it took 2 minutes and 8 seconds, and that should be running the other ones. Now we see that this one took 2 seconds to run, and then I think we're running one more time. And oh no, it's still running. Oops. I keep switching windows. Oh yeah. Also, so on the code cell, there's a by default the poll I think is 30 seconds. So it always show like 30 seconds down here, but the actual task is way faster. Now it should be going. And this one only took 1 second. So once we spun up that container, again, we can reuse it and not have to wait for that spin up time at all. Someone said new to machine learning, small projects on Hugging Face. Awesome. Hugging Face is really, really cool. I'm not sure if you're using like their spaces or their data hub or all of it. They have really cool stuff. They have really great courses right now too. Like their agents course is really good. They're refreshing their large language model course. They have some really good learning content. All right. With that, though, I think we've really shown all the stuff I had prepared and more for you today. So I will look forward to hopefully seeing you at other workshops or just in the community asking questions, maybe at book club even. You can find it in the Slack channel. Go to the AI Reading Club channel. And there's links to the next event, which is next week on June 17th. Usually we're later in the month. Like I try to do the last Tuesday of every month, but I'll be on vacation. So we're doing it a little earlier this month, but we're also reading a shorter book. So it worked out well. I said spaces are cool and Hugging Face. Yeah, they're really, really neat, cool way to host like a portfolio project. And also, like you saw, you can do that here with managing your compute a little bit more, at least in kind of our free tier. I think they might do that in there if you pay for it. I'm not sure how that works with spaces actually. Yeah, all some other cool examples for you to look out soon. I know agents is on everyone's mind, just like the chat said. So keep an eye out in the next couple months. I think you'll like some cool stuff that we're working on. Also, one last question still. Does anyone have a agent framework they've used that they have enjoyed? I've been playing around with small agents, which is Hugging Faces. They're pretty cool, lightweight one. They do code first agents, Llama Index, LangGraph. And then also I've been playing around just implementing most of the stuff without a framework, which is one, a really good learning experience. And then also what a lot of people might end up doing in production later too, just depending on how framework adoption works. Like they're really, really good at prototyping and building stuff. I haven't put as much or like an actual agent with one of those ones in production yet. So we'll see what happens. I'm kind of curious where the industry shifts, but it's not that hard usually to actually build your LM kind of evaluation loop and then tool calling. So if you haven't done it yet, I would recommend playing around with building an agent without a framework. And you can kind of see what's going on behind the scenes and have full control. Not saying you don't want to use a framework. It's just fun to go through. All right. With that, I'm going to actually end the live stream. I think I've said this a few times. Then I go off on tangents while talking to people. I'm going to hit end. Thank you, everyone, for coming. Hopefully, I'll see some of you in Slack or some other workshops or community events. And I'm in Seattle. I usually go to a lot of meetups, too. So if you're in the area, you'll probably see me around. And goodbye. Talk to you all later.